Hi, everybody. I'm Garren, Solution Architect at Databricks. I work in the West Coast. I'm in Seattle area. And here we're today to talk about Databricks and Snowflake, catalyzing data and AI initiatives. So here's my contact information. You can reach me at garren@databricks.com or Twitter @gstaubli. I will say also at the bottom, slides and resources. I try to make all of my content available to you. So this link will actually be available throughout the entire slide deck. So if for some reason you don't get a picture now or you don't want to get a picture, I don't blame you. Just garrens.com/data-snowcat. It is case sensitive. I haven't reconfigured it to handle insensitivity. But ultimately, I will put all of these slides and potentially some more information on that link. All right, so today I really want to go through kind of our agenda of what we're going to cover. The first thing is introductions to myself, Snowflake and Databricks, as well as the scenario we're going to walk through in how this comes up. Some of the key challenges that take place, their relevant solutions to those, and then finally a demonstration of how this all comes together in one flow. All right, so I apparently messed up the animation on this slide because this was supposed to show you kind of just my progression throughout my data career. So fundamentally, I've been working in data my whole career for the most part. So it comes down to I do tons of data engineering, a little bit of science, done administration, DevOps even, and all sorts of other stuff, lots of analysis. Now, what is Databricks? That's kind of a key part of this equation because we are talking about two different technologies. I'm sure most of you are very familiar with Databricks and Snowflake to some extent, otherwise you wouldn't be here. There's kind of an interest there. So Databricks is a unified analytics platform that's going to help you do the extract, transformation, and loading that brings together the engineers with the data scientists and business users to create this unified workspace so that you can have all of this sitting on top of the cloud, running in the Databricks runtime, so you get the performance benefits of the Databricks runtime as opposed to vanilla Spark, and you get all the prepackaged components as well. And finally, it's a collaborative workspace that allows you to do all of this work, all these workloads, from extraction, transformation, loading, as well as the machine learning pieces. So accelerated innovation by unifying engineering and science. What is Snowflake? So Snowflake is a cloud data warehouse as a service. And so fundamentally, it's designed for the cloud. So it's a cloud data warehouse. It's all about SQL. It's very SQL heavy. It's very SQL powerful as well, because it's fundamentally sitting at the core is all SQL. You can interact with it in every single way. You can administrate it even using SQL. And it's delivered as a service. So contrary to some traditional data warehouses where you have to set it up and configure it and monitor and maintain it, Snowflake is a data warehouse as a service platform. So you don't have to deal with that setup and configuration. All of it's managed on your behalf. And it's super simple in that regard. I'm sure I'm kind of preaching to the choir here. But that's what makes it awesome in this regard too. Forget oil though. Data is worth more than gold. So here's the scenario. Ultimately, you want this. You want Fort Knox. That's what your data is. This is where all your data lives. That's the money that you're generating by taking your data and making it into an actual asset. But how do you get there? How do you go from your raw? You've got raw data. It's sitting out there. You've got to mine it. You've got to grab it out of the ground. And there's a bunch of garbage. There's a bunch of dirtiness inside of there. So you have to be able to filter out all of that stuff. You have to know even where to look to find that data that's going to be relevant. Then you have to start processing it, giving it some form so you know what you're working with. So you've got some gold nuggets. Then you've got to bring that down, distill it to a lower level, pour it into actual gold bars that then get quality checked and verified. And finally, you have to distribute that and actually put it into your storage. But how does this this is a cute analogy, but how does this work in the real world? Well, here's how. You've got data mining. That's your first piece. That's going and grabbing your data from your core databases, your data lakes, et cetera, grabbing all of it to start. Then you got to start to filter it out. You got to start digging into it, figuring out what's relevant. Data science is then turning that into little nuggets of gold to try to get that value from it, which, by the way, this is obviously very overly simplified. So if you're laughing a little bit, I don't blame you. It's just meant to be a cute illustration, and I kind of like these cute illustrations. The next part is ML engineering. It's taking those nuggets that were found and turning this into an actual process that creates this final product. You've got your processing that creates your nuggets, then you've got your ML engineering that's going to create your gold bars that ultimately matter. The next piece is QA. You've got people going in there testing, validating, ensuring that what you created from all of the workflows so far is actually what the customer wants, and you don't have some non-gold components getting in there, because you don't want to create some fake gold unless that's your gig. And you've got DevOps. DevOps is responsible for taking all of those products that you've built, and delivering those to your final location. They need to take all of your gold, all of your data that you've done all of this work to, and put it back where it belongs, which is in the hands of the consumer to give you the money. And so this is your production delivery, not DiGiorno. Now, the reality is, however, that you want all of this data. You want the value from it. So that's still the gold bars. So we've got the same gold bars as the output. But the reality is that this is what your input looks like. You've got data. It's in a dumpster. You got to filter out the garbage. You got to filter out the stuff that just doesn't matter. But you know that there's gold in there. That's the thing. You've got to do some magic. That magic is that whole machine learning piece, the engineering piece, putting all of this stuff together. And then you finally get the gold bars. But what you want to avoid is this, the dumpster fire, where you're going in there, you're looking for your data, and all you're finding is a way to create more problems. So putting this back to reality, so I'm kind of moving on from the cutesiness. I think we should talk more about reality here. What this looks like is you've got a whole bunch of different data sources coming in. You've got SQL servers, you've got NoSQL, you've got data lakes. All of these different things, including streaming, come into play, and you've got this big question mark. The business cares about the output. The engineers, the scientists, and everybody else cares about the input. But there's so much in between of how you go from point A to point B. How do you get from your sources to your final output? And that's what we're going to talk about today. So here's an actual scenario that has come up. You've got all of this data coming in through Kafka, coming in through, it's landing in your lake, effectively. We're getting close to swamp level here. All of this data is coming through constantly. You've got feeds coming in. You're landing some CSVs, some JSON files in S3 or Azure. And you've got all this data coming through. And you want to start running some processing on this. You want to start your extraction, your transformation, your loading to get it ready for use cases. Then your machine learning and analysis to finally reach your pinnacle, which is your actual insights, to make real business value from that data coming in. But how do you get there? So some of the first core challenges of doing this type of processing and getting that insight comes down to ETL, because so much of what we do ultimately comes down to how do you get all of that garbage out of the way and filter through it, find the signal, and get away from the noise. So the first thing is you've got sources. So these are all the different places that you're accessing data from. And that could be anywhere. That could be those streaming systems, like we said here. In this case, we'll just stick with streaming and our CSV and JSON. So you've got to be able to access all those different places and be able to do something with it. You've got the syntax of how do you actually interact with that. You got to start worrying about scale to some extent, especially when you're talking about pretty decent size data coming through in this use case. Languages and performance start to matter because your engineers, your scientists only write in certain languages, and they're expecting a certain level of performance, and that's critical. You want to make sure that what you're doing is going to be useful both now and in the future. And finally, expressiveness. So what we get out of that is you've got all these different sources that you can connect to, from flat files like CSV and JSON to relational databases, streams, etc. For syntax, you can do unified and batch APIs. Scale, there's this idea within Databricks and within Spark of scaling. So you can bring the machines up and down to scale and reach those limits that you need. You've got 5 different languages to choose from in this scenario. Behind the scenes, it's all running in the Java virtual machine. So you get the performance of a really robust system. And finally, multi-level APIs. So you can work at the high level where you're working with something like SQL, or you could drop down and work with something more fundamental to Apache Spark. And I totally beat myself to that punch on that one. But there's Apache Spark. So fundamentally, Databricks and Spark is the first piece of this, where you're able to do that ETL. So now we've got that piece out of the way. The next thing you got to start worrying about, once you've done that extraction, you're onto the transformation. So now you have to worry about things like malformed records and errors. How do you handle when things go wrong? Changing fields, so you've got some sort of schema modifications as they come through, whether you want those or not. Writes, so when you're actually going to write it back out. And so that comes down to performance, semantics, and reliability, because you want it to be fast. You want it to get you the data that you actually want. So you don't need duplicated data, for example, or where you've got race conditions and data gets written or it doesn't get written and you don't know. And so the reliability piece is critical as well. You want to make sure that what you're getting is what you expect to get. So how do you solve for this? You first start by the ability to ignore/infer and log records. So something comes through, it doesn't look quite right. You want to be able to process it out and either ignore it or do something with it. That's part of also the error piece, where you don't want one record, for example, to just throw a whole curveball into your system and be a grenade that just stops the whole thing from working. So you can retry with checkpointing. Schema evolution is you've got all this data coming through, you've processed it, but then you suddenly start getting a new feed. Something changed, it became a double instead of an integer, and you want to be able to handle that. Or it became a new column was added that was not in the original data. From the performance side, you can then have things like partitioning and optimizing files so that you don't end up with a data swamp or just non-performant systems. You can get the exactly one semantics of something that's been written to the stream, for example, actually only writes to it once, and you don't have any concern about whether that's going to come up multiple times. And finally, to round this out, ACID transactions. So you have all of these different things solved for in the Delta Lake, which was open sourced as of yesterday. If this is your first session at Summit, welcome. So Delta Lake is going to help solve a lot of those problems. Oh man, I've messed up my animations again. All right. Well, I guess we spoiled the fun here. So then data access comes down to Spark and Delta together so that you can have the performance of Spark and Delta to get that access to all of your data and ensure that you actually have that. So this is for machine learning now. The syntax, so now we also open sourced and made available koalas. So that's going to allow you to write code in Python pandas-esque APIs, but it would actually run in Spark. Collaboration through Databricks Notebook, so you can actually have multiple people working on something, collaborate on that, be able to see revision history, commit that, all that good stuff. And then on the model piece, there are 3 different factors that tend to come up a lot, at least with my customers, which is iteration, reproducibility, and deployment. So iteration being you keep trying new versions of models, you're tuning it, new parameters, new hyperparameters, and you want to try to get to that final output of a particular model, and you want to also track which metrics are going into that. So there's a whole bunch of different things to kind of juggle up in the air, and I've seen people use Excel, And MLflow is meant to help solve that with tracking. So these are kind of the 3 pillars of MLflow. So you've got tracking that will keep track of all those models. Oh, sorry. Projects, so that's the next piece of you have an ability to reproduce all of your code and actually build a pipeline that's going to ingest data, do some machine learning, and finally pump out a model and do this all in a very reproducible way. So you can hand that MLflow project off. And finally, a model. So now you can actually log models, log the artifacts that go along with it, including charts, for example. And then how do you handle analysis? This is obviously a critical piece as well, because so far we've gone through Spark, we've gone through Delta Lake, and we've gone through MLflow. So we've handled the ETL, we've handled the machine learning, and now we've got to figure out, okay, well now we want all of our users to be able to run analysis on top of this, and even use this in a machine learning context of you've got all of your data nice and pure, it's ready for machine learning, it's ready for business analysts to work on it. And so your challenges are you want your analysts and ML folks will want time to value. They want to be able to work quickly, so they get interactive queries through Snowflake. They're going to have intermittent demand. They're awake at certain hours of the day, they're sleeping at others. They're running big workloads, different points. The instant scaling of the cloud data warehouse is going to be key to that. Language, obviously, so much of this is based around SQL, because SQL has so much staying power that naturally that is a perfect fit for this scenario. You're trying to do all of this analysis, do all of your grabbing of the data from Snowflake. And so common tooling frequently is our BI tools, Power BI, Tableau, and the ease of use. So Snowflake, because it is a data warehouse as a service that's hosted in the cloud, you don't have to worry about how to configure it, how to set it up, maintain it, any of that stuff. You can trust that when you run a query, that's your job, is to run the query. It is not to handle all of the setup and maintenance of the system. And finally, cost control. So Snowflake, just similar to Databricks, is a decoupled storage and compute. In Snowflake, all of the data lives inside of the Snowflake account on the cloud provider. And Databricks is the data lives inside of your account. So it's a slight difference there. But fundamentally, they're both decoupled. You pay for storage, you pay for compute. You can have compute running and not have much storage if you had some strange workload. But more often than not, you're going to be always paying for storage, and you're going to have kind of flexible compute. And so the way that this ultimately pans out, as you're seeing from my final solution architecture slide, is all of this data comes through from Kafka, from CSV and JSON and S3. It goes through Databricks. You've got Spark and Delta Lake sitting there to help build this ETL pipeline that is going to be reliable. It's going to give you that performance that you're expecting and ensure that you've got those ACID transaction compliance backed by in a true Delta Lake manner. Then it's going to go to Snowflake with that pure data that's ready for analysis, ready for machine learning. And then at the top piece, you'll see that the machine learning piece is in Databricks using MLflow. And so critically, now you've got 2 different areas that you can pull from to do your machine learning. If you're using a pure data set that's ready for analysis, you're going to pull that from, say, a reference table in Snowflake. You're going to do your analysis on that. If you're using some new data set that you're not ready yet for analysis, it's not ready for kind of that business user to be messing with it just yet, you'd leave that in Databricks, for example, in the Delta Lake, and have it grabbed from there directly to do machine learning. So you can do a join on those 2 tables, for example, to start doing kind of model development and testing. And finally, the user would be running this through reporting dashboards. So, or at least that's one of the use cases. So Databricks for ETL and machine learning, and Snowflake would be serving all of these queries in a super concurrent fashion. And so then we move on to the demo. All right. All right. So part of the point of this, or probably the main point of this, is really to show you how the Databricks interface works, along with Snowflake, and how you do this in reality. And this is just an example of how you might do this. So this is going to show you at the start is we have the Databricks environment. So this is a Databricks Notebook, if you're not familiar with it. On the left-hand side, you'll see all of the different kind of core tabs that are open with the Databricks environment. So you've got home and workspace. This is going to be folder directory structure to tell you where you're working, as well as the data and clusters to figure out where your data is living in tables, and clusters for this is the ultimate compute piece. So this is where the compute lives. So if we were to go into here, we would see that this is all the different types of clusters that are running right now. This is mine, as we're going to go through in just a moment. So if I jump into here, I will see that I've got the Databricks runtime of 5.3 ml. So what this means is the core runtime has Spark and Scala at certain levels. So in this case, it's Scala 2.11 and Spark at 2.40. But then it also, you'll see the ML piece here. And so what the ML piece does is that adds in the machine learning libraries and functionality gets baked in as well. So you can run packages like pandas, like NumPy. All of those get baked into the Databricks runtime so that in addition to Spark, you can run all of these things, as well as PyTorch, TensorFlow. There's a whole slew of different systems that get baked into here. Now, I'm using Python version 3 for our benefit there. And finally, I have the worker type set up in this case, where I can have the most optimized workers, because these ones will give me access to caching within Databricks Delta that brings the files down to the local machine. And then there are advanced options. In this case, we're using spot instances, and these are all the different configuration options that are available. So I can go look at the JDBC, and I can see that this is how I might connect to a table through JDBC, or any number of other configuration options. So one other thing I want to point out is that you can also install libraries directly through here. So if there was some library that wasn't on here, by the way, I got a little greedy and tried to get 1.0 of MLflow because that just came out today. As you can see, I failed. So in this case, if I wanted to add some new library that wasn't in the runtime, I could add this using this interface, whether it's from Maven, whether it's from PyPy, and it will install across the cluster. And then there are all sorts of other information. So if I need to debug something or understand what's going on, what's the performance dynamics, I can jump into any number of these other tabs. So that's a super quick blitz of Databricks in a nutshell. But then back to the notebook. So think of this, if you're familiar with Jupyter or any number of other notebooks, Zeppelin, for example. This is the same concept. It's just this is automatically hooked into all the Databricks runtimes. So you don't have to install Spark. You don't have to install Pandas, et cetera. All of that stuff is pre-built for you. So in this first cell, this is kind of demonstrating how we're going to connect to Snowflake, because we're going to be grabbing some data, doing some ETL on it, putting it into a Delta table, then passing that over to Snowflake once we've got it ready. In this case, it's a fairly simple demo. So I'm not really doing anything to it. And then finally doing some machine learning on that, and then giving the results of that machine learning back to Snowflake so that I can report on that in later sessions. Now, what I'm doing here is I'm using the secrets utilities. So this is going to securely retrieve all of these secrets from our interface. So in this case, there's no secret stored here. So even if I leaked this whole notebook and just sent you guys all the notebook exactly as it is, you could try as hard as you want, but you're not going to get the password and the username to our Snowflake environment that we use here. That's not a challenge for any of you hacker folks out there. Although if you're interested in that, I would be interested in that too. So what I'm going to do here is just set up the environment. So I'm going to say, this is where I'm connecting to. This is my user and password, so I'll go ahead and run this. There's one cell that I might not run live just because it will take a few minutes. So then the next piece is this is going to set it up so I can run queries directly in Python. So normally we do this demo and we actually have a Scala cell, so it switches over to Scala temporarily, and then just to run this code, because the Snowflake utilities I don't believe are made available directly in Python. So in this case, we're going to just hook into the Scala utilities using the, this is a very hacky way of doing it, but this is a way that I kind of like, because it makes it all one line. So it's kind of nasty, but it ultimately works. We hook in, we grab that, and we're able to run queries now, arbitrary queries. So these queries that I have here are going to run in Snowflake. They will not run in Databricks. It's just purely an execution layer to where it's going to run this. So if I go ahead and I run this, so what this did was it just hit 3 queries, sent them off to Snowflake. So if I jump over to my Snowflake interface, so by the way, this is Snowflake. Should have caveated that. I'm in probably the worst part of it, so that my bad there. So if we just go back to the home, this is where you might land if you're coming straight to Snowflake for the first time. So this is the kind of base level interface that you're going to come into when you have your own Snowflake database set up. So at the top, all right, there we go, much better, hopefully. At the top, you'll see that there are databases, there are shares, there are warehouses, and there's history. Those are the main tabs. Then on the right side, it's more administrative around connecting and help and user information and profile, all that good stuff. But fundamentally, that's the interface we're working with. And databases is similar to what you're used to, except there's layers to it. So if I go to my databases tab, and then I jump into my database for demo, I can see that these are all the different tables I have. You'll notice there are also views, so I can see the different views that are out there, as well as schemas. So these are the different schemas inside of that database. Stages, so this is where the files might land when they're going to be transferred in between the systems. So these are the different stages that you can use. So this is not a thorough Snowflake demo, by the way, if you haven't learned. I'm trying to go through it as quickly as I can so we can understand the full dynamics. File formats for when you're ingesting files in that regard, and sequences. Then there are shares, if you're going to share data between, and warehouses. So this is a virtual data warehouse. So this is a key part, so I'll spend a moment on this. This is where you're going to actually set up your compute. You're going to say, I want a certain number of machines. So in this case, I might choose a small or a medium, depending on the size of my data. And so now I can scale up and down. I can create multiple clusters effectively to work with these different workloads that I have coming. In my case, I've already pre-built a cluster, so no concern there. And auto-suspend, so the machines I will not be billed for them if I don't use them for 10 minutes. All right, and then you'll notice, actually, I think that is worth pointing out. You'll notice here that there's a show SQL, which I actually probably should have done this right. So I need to provide a name. But so this just speaks to just how SQL strong and SQL-oriented Snowflake is. In this case, I can hit show SQL, and it's going to give me the actual command to run if I wanted to run this and do this administration type work in SQL, which is really cool, really unique. So, all right, we've got that. Now moving on to the more fun stuff. So this is a worksheet. So this is where I can actually start to interact with my data. And you can see over here that I've got my database. And then I'm inside the Databricks demo schema. And then finally, I've got all these different tables. Now, in my case, we're going to look at history for now, though, because history is the queries that have been run against my Snowflake deployment. So you'll see here, now that we went through that, that this is the actual table. So this is the same query that I ran in Databricks, but it actually ran, as I said, in Snowflake. So if I were to look, there is no Databricks demo.adult table that exists in any way that Databricks directly is using right now. So now that we have our table set up in Snowflake, we've pre-configured it with columns and types that we're expecting. Now I could read from a CSV file in this case. And what it's going to do is I'm going to read from a CSV file, tell it that it has no header in this case. I'm going to infer the schema, so it's going to figure out exactly whether it's doubles, integers, strings, et cetera. And I'm going to tell it the exact path of the file that I'm going to be reading from. Then I'm going to, because I know that it has no header, I'm just going to tell it I want to give it these column names because it doesn't know what the columns are. So what we get out of that is a data frame. So that's what this data frame looks like. Age is an integer, work class is a string. OK, I have a good idea of what that looks like now. Then I'm going to run these functions. So what I'm doing here is I'm dropping a table within Databricks. So this is saying this table doesn't already exist, or if it does exist, go ahead and drop it, because this is a delta table that I'm ultimately going to be creating. The next line is just specifying the location of this delta table that I'm going to want. This one just is removing it in case it is there, so it's just going to delete the whole record, because ultimately Delta Lake is going to store it as Parquet files in the Delta Lake with a transaction log and all these goodies that I want to remove that, because this is ultimately living in your own lake. This is living in your own storage account. This is not stored in our account in any way. So in this case, I'm removing both the table, the metadata connection that links to these actual files in the Delta Lake, and so I'm removing both. I'm getting rid of the metadata, which is here, and I'm getting rid of the actual data, which is here. Then finally, this is where I'm actually doing my write. So this is where I'm saying, write this as a delta table with this path, providing that location, and save it as a table, Garren's demo adult. All right, so now I've got that table. Now it lives in my Delta Lake. So if I went and ran this command, it's going to run this command, and it's going to be hitting the Delta Lake inside of Databricks. So now it's going to go into your account, going to retrieve those files, going to return them back so I can have a pretty view of it. And you'll see that I can directly use SQL inside of here. So I can switch between languages inside of the notebook seamlessly. So now I can get a good idea of what this looks like. OK, I've got all these users, all these people, and I've got income. So hint, we're going to be playing with this in an income prediction sort of way. So we can see that the categories that we're going to be working with are income less than or equal to 50,000 or greater than 50,000. So surprise, we're going to do a classifier to say whether it's greater than or less than. Then what we're going to do in this case, I did not do any actual feature engineering in this case, so this is just a kind of a simple example, is we're going to read from our Delta Lake table, and now we're going to write it out to Snowflake. So this is just going to go into Delta Lake, and it's going to go into Snowflake and just write out that data back. So now Snowflake has access to that pure data that's ready for analysis, ready for ML. So then we start to talk about the ways to read the data. So in this case, we're going to read that same table back from Snowflake into our notebook. Now, you might say, oh, but I could just use the same data in my Delta Lake. Yes, you totally could, and that's totally fine. In this case, I'm reading it back from Snowflake because I'm trying to show you how this integration would work normally. So this is just going to read that same table back. Then I'm going to just display that, because we're going to see the same data. But the difference is now this query that's reading, instead of running this on the Delta Lake, this is actually running it on Snowflake. So if we go back into our in our Snowflake, and we refresh, we can see, yeah, that is useful, but not as useful as what I want, which is this command. So you can see that this is the query display data set running in Snowflake. So now I can see that this query is running directly in Snowflake, and then it's just returning it back via the Snowflake stage. Whoop. But another thing you can do is actually just read directly from a query. So in this case, instead of reading from the whole table, I only want people that are over 18. So this is going to still go into Snowflake, run this query. All right, I'm not going to show you that because we're running a little lower on time. But so this is what we'd see if that's the case. Well, it's still tiny. OK. Anyways, we would see the fact that it's running this whole query in Snowflake. But that's not as interesting as what I'm showing next. What I'm showing next here is the idea of a connector query pushdown. So this is the Snowflake Databricks connector that we both built in tandem. And so now what we're able to do is we're taking our original data set. This data set is from for all adults or all people. So actually, there are people in that data set that are under 18. And so this is going to, that data set variable has only access to, or it has access to the whole range of people, whether they're over 18 or under 18. But now we're running a filter operation. So you might think off the bat that this is going to run a filter operation after pulling the whole data set down from Snowflake. But actually, this is going to do the filter in Snowflake. So it's going to do a push down. That Spark is going to see, hey, I see you're doing a filter. I see you're doing some query changes to this data frame in Spark. But I see that this is connected to Snowflake. And I can actually push these different parameters down to Snowflake. So unlike this version where I'm explicitly telling Snowflake I want to run this query, in this case, you might think that it would run in Spark, but Spark is smart enough to push it back down to Snowflake. So now if we look, in fact, I'm just going to kind of skip and go to the part where we see how this worked. So this is what's happening. This is just me trying to save a little time. This is what would be running. Ultimately, it's going to select, do this whole statement, and it's going to run it in Snowflake. So instead of it, normally, it should only be select star from adult, because then Spark would do the filtering. But because it has the smart query pushdown, it will be doing that filtering directly in Snowflake. So now Snowflake's going to do the processing, going to send only the data that's relevant to my query. And so I'm going to see people that are under the age of 18 with capital gain or capital loss greater than 1,000. So now I can see that there are 32,000 people that are over the age of 18 in my data set, and 395 that are under. So then we can do some machine learning. We can take that data set that we have from Snowflake, and we can do some feature engineering. So for the sake of time, we're moving past that a little bit. Then I can build a pipeline that's going to actually declare how this is going to run, and it's going to run some of this. So that's going to run, I think that should be fairly quick. So then I can see that when I split my data, I'm going to get 70% of it would be in my training. So I'm going to use 70% for training, 30% for test. So 22,000 rows for training, 9,700 for test. So I'm going to use a random forest classifier so I can get high accuracy, because I really want to understand, based on these features going into this model, what's the likelihood that they have an income greater than or equal to 50,000 or less than 50,000. So now I also want to do some parameter grid building and cross-validation, because I really want this model to be as accurate as possible. So in this case, we're going to do a 5-fold with a bunch of different parameters. Then we want to do evaluation using a binary classification evaluator. And now we can actually set up our cross-validation. OK. Yeah, so this is actually the slow one. So actually, I think for the sake of time, we'll just skip that. That takes about 3 minutes to run. It's only a pretty small cluster. And it's a lot of model building in there. So then we can take our best model out of that I predefined. And now I can grab that best model and apply those results of that best model to my data set. So now I can see that my accuracy is about 0.9, which is not too bad, especially for kind of a first pass at this. So then we can start to actually look at it, play with the data, play with it. And we can say, OK, I've got all these predictions, and now I can sort that by random so I can actually start to see how well this did overall. So I don't bias myself to thinking that it's some great model when it's really missing a lot. In this case, it looks pretty good even when I sort by random. The label of greater than or equal to 50K or less than 50K is consistently predicted. All right, cool. So then we're going to declare some helper functions in this case and register a UDF in Scala. It's because it's frankly just a little bit easier in Scala in this case. And we're going to display the final result of that function. So what this is going to do is it's going to give us an idea of what Spark machine learning ultimately figured out for the probability of whether that was a 1 or a 0 in the classification to say that this person was likely above or below that 50,000 mark. So you'll see in some cases it's extremely high. We know that this person fit 0, so they were not above 50,000, I think is the result there. And so we had very high confidence of that. In other cases, it's a lot blurrier, where now we're somewhat certain. All right. So then what we can do with that at the end is write that out to Snowflake. So now we've got our model. We processed our model. Let's just finish this up quick. I'm out of time. But moral of the story, we built our model. We trained it. We built all of these. And all right, yeah. This is our final result. The end is that we were able to ingest data from CSV, write it to the Delta Lake, use that to write to Snowflake, run our machine learning on top of that, and then an analyst would be able to process that and do their own learnings on top of that. Tableau, Power BI, SQL editors, et cetera. And so go ahead and rate this session. Go to your app. And this might be the worst episode ever, so feel free. Thank you.